About 2 years ago, when we were introducing Polymaker PLA, I reached out to high-speed 3D printing expert Albert from 24/7 Printing to get his thoughts. He was genuinely excited to try it, but he also shared a comment with me that really stuck. He said, "I really hope that one day these high-speed filaments just become regular PLA. From my customer point of view, we don't need any more complexity." At the time, high-speed materials were necessary. Hardware was evolving faster than materials, and Albert's point of view was simple and honest. And it turns out he was right. If we fast forward to today, 300 millimeters per second is now considered normal, and many printers ship capable of that straight out the box. But speed numbers alone don't tell the full story, because once you look at volumetric flow, layer height, and real mechanical performance, it becomes clear that while printers got faster, materials were still playing catch-up. So rather than asking, how do we make another high-speed filament, we asked, how do we make PLA better? And that question led us here. Introducing Polymaker PLA Pro, a brand new formulation that combines the toughness of Polymaker PLA Pro and the high-speed mechanical retention of Polymaker PLA, unified into one material. No special labels, no trade-offs, just PLA done properly. PLA Pro launches in 32 colors, including 9 metallic options. That's one of the most comprehensive color offerings we've ever released, because strength shouldn't mean compromising on aesthetics. And if you're based in the USA, then this product is made in the USA. Whether you're printing functional prototypes, end-use components, PLA Pro gives you the flexibility to choose both performance and appearance. But what does the Pro actually stand for? PLA is naturally stiff and easy to print, but it's also brittle. Impact resistance has always been its weak point. PLA Pro changes that, and we've increased the impact strength by over 500%. That number matters because impact resistance is what determines whether a part survives real life or fails catastrophically. Drops, knocks, accidental bumps, these are all things that traditional PLA struggles with. To achieve this, we compound a thermoset nanoparticle into the PLA matrix. Here's a simple way to think about it. Imagine millions of microscopic bouncy balls woven into the PLA polymer chains. When a printed part experiences an impact, those particles absorb and then dissipate the energy, allowing material to flex and recover instead of cracking. That's the difference between a brittle failure and resilience. And this isn't just something you see on the datasheets, you can also feel it immediately on the filament itself. Here we have a spool of Polymaker PLA Pro and a spool of Polymaker PLA. If we try and bend this filament, we can see it snaps. If we try the same thing with the PLA Pro, you can see that the filament bends and bends and bends and bends, and eventually it will give up. To take things one step further, I've just rigged up this rudimentary system with a hammer on a pivot. We've got some elastic bands to pull the hammer down. We've got 2 little clamps to hold the parts here, and we've got this part printed with 2 walls on the same printer with the same settings, the red one in Polymaker PLA and the teal one in Polymaker PLA Pro. Okay, so we'll try first with the Polymaker PLA. We'll just lock it in the clamps there, bring the elastic around the hammer. You see after 3 blows there, we've got a really brittle failure. It's completely shattered away this side of the part. If we swap in now the Polymaker PLA Pro, and again we've got 8 elastic bands on here. We'll hold it to the same height. So I wasn't counting the exact knocks there, but we've given it a lot of a much harder test there. If we compare these now, these 2 parts, we can see the Polymaker PLA has very, very brittle failure mode compared to the Polymaker PLA Pro. which is really deformed. And the key here is the stress whitening that we see here. So the part is deformed under the impact, but it hasn't cracked and failed in a brittle nature. And this is just with 2 walls and 15% rectilinear infill. No exotic settings, no reinforced designs, just smarter material behavior. So what does this actually mean for you? It means that you can print parts that survive the bumps and grinds of everyday life without sacrificing the ease of printing that makes PLA so popular in the first place. Does this mean you can print a basketball and actually play with it? Well, no. But you can print functional replacement parts like this suitcase wheel that don't shatter the first time they hit the pavement. That's the difference. And this brings us back to Albert's comment. As printers standardized around higher speeds, the idea of labeling a filament as high speed becomes less meaningful. Speed numbers alone don't define performance. Strength at speed does. That's why the need for Polysonic PLA has gradually faded, and that's also why we'll be phasing it out, replacing it with something more capable. Polymaker PLA Pro delivers strength that scales with speed, impact resistance suited to real-world use, a truly wide and consistent color range, and the reliability PLA users expect, all in one material. Less complexity, more capability. Materials that evolve alongside the machines. That's what PLA Pro represents, and that's why for us, this isn't just a new filament, it's a new baseline.